Hello, everyone, and welcome to our webinar today. We will be waiting a couple of minutes for the other attendees to have the chance to join the meeting as well. So we'll be seeing each other soon. Thank you very much. All right. Thank you very much, everyone, for joining, for your patience and your time. Welcome to our webinar together with, webinar from PVRADAR and Terabase PlantPredict. We'll be presenting today how PlantPredict users can now maximize their project value with the optimal cleaning strategy through the PVRADAR soiling extension. We'll be starting. Just let me perfect accept these people. All right. Kind of reminder for everyone, during the webinar, we will be presenting some slides, but the main part of the webinar is a demonstration, which will be performed by David and also then complemented by me. And the idea is to showcase how PlantPredict users can now access a site-specific soiling loss values for their projects and also increase the value of their projects through the optimal cleaning strategy. Please, if you have any questions along the entire webinar, just feel free to drop them in the Q&A section. We will be addressing them at the very end of the webinar, so I'll be happy to get your questions. Right, so let's go with this. The agenda for today. We will start by talking a little bit, introducing both companies, PVRADAR and Terabase. Then we will jump into taking what is the problem today. So today we have soiling assumptions as the main method to estimate these losses for future projects, and also why fixed cleaning strategies are far away from optimal. Then we will jump into the demo, how to maximize project value with finding the optimal cleaning strategy. And finally, we will explain how you can access the PVRADAR soiling extension today, and we'll be announcing a special cleaning season or summer promotion for everyone that is interested in that. So together with me, we have David. David is Director of Sales from PlantPredict Terabase Energy. Hi, David. How are you doing?
I'm good. Thanks, Franco.
Great. So, and from PVRADAR side, it's me, Franco Clandestino, Head of Product at PVRADAR. And let me kick off things by telling you a little bit about PVRADAR. So, PVRADAR is much more than a soiling assessment tool. We are a framework for advanced PV modeling, PV and BEST modeling, that help teams solve challenges across any stage of a project life cycle in a flexible and transparent way. Depending on the use case, we provide different solutions. So for performance engineers who want greater visibility into plant performance and a breakdown of the different losses, PVRADAR enables the development of digital twins and internal tools through our Python SDK. Then for project developers looking to identify the optimal plant configuration, we provide automated PV plus BEST design optimization workflows. For engineers that need accurate site-specific estimates of soiling or snow losses, we offer the Soiling and Cleaning app, which is an intuitive solution that provides site-specific losses during project development, and also it can be used in operation, as we're going to see today. And this is a product that we have this extension with Terabase PlantPredict. Finally, for engineers that need established internal workflows, we offer our solutions also through APIs. For example, we have the Soiling API, which provides history and forecast of the soiling conditions for any project around the world. David.
Sure. Thanks, Franco. So Terabase Energy, for those of you who are not familiar with it, is a digitization company. We are trying to digitize utility scale solar. So we have 4 different products that you can see on this slide. So PlantPredict, which is what I'm responsible for, really lives through the life cycle of a solar power plant project. We also have a construction vertical where we have our construction management platform that uses drones to capture imagery and then monitor progress on a project. We also have our SCADA product, because every solar project has a SCADA, and that's where your control and data collection all takes place. Our SCADA product is really widely used. Tens to hundreds of gigawatts of projects have used our SCADA product. It's really powerful. And then the big deal is our TerraFab automation system, which uses robots and AI to automatically install a large-scale solar power plant, which is really pretty incredible to see. We've deployed this on over 100 megawatts of projects thus far, with plans to like double and triple that this year, and then really scale up into gigawatt scale next year. So stay tuned on that. All right, next slide, Franco. All right, this is a very busy slide because there's a lot going on here. And this is something that we really want to get across in this webinar, is that PlantPredict is built API first. What that means is our developers deploy logic into our API when they roll stuff out, and then we update our user interface to interact with that. This has been part of our strategy back all the way to the beginning. We had no idea how powerful this would become in today's day and age, but it allows us to easily integrate with other cloud-based solar software providers like PVRADAR, and we're going to demonstrate that today. But as AI becomes a more common theme in the world that we work in, and people start using tools like Claude or Cursor or ChatGPT, this AI first strategy is really a powerful force, because now our AI agents can automatically interact with PlantPredict through that API layer. And then we have an MCP server, which really helps manage that communication. We're on beta with our MCP server right now, and I'm going to demonstrate some of that today. So we're really excited about this because we see this as the future of how software is going to interact. And I think that many of you are probably experiencing that for yourselves today. I'm going to just demonstrate a little bit of that in today's demonstration. All right, go ahead, Franco.
Great, thanks, David. We would like to start by, well, from the base. So what is the problem? What is the current status today? And the true cost of soiling. Soiling is, by many studies, placed as the second largest single source of yield loss in utility scale solar after irradiance, but yet it remains unsolved. And here are the problems associated to the three different approaches that organizations in general take. So the first one is teams that use or trust generic assumptions. Most projects rely on the standard 1 to 2%, only one value for the entire project. And they input this into their yield estimation tools. The problem is that soiling is highly variable. It changes with location, season, and plant design. So just a single value cannot capture this complexity, resulting in poor bankability, unreliable P50, P90 estimates, wrong OPEX budgets, and in general, just an unrealistic project value. Another approach are teams that rely on rough estimates. So some teams estimate soiling losses using simplified models or quick Excel calculations based on site experience, for example. The problem comes when stakeholders challenge those assumptions because defending them turn to be really painful. Without a clear and traceable methodology, every question becomes harder to defend. And then finally, we have teams that try to proper model soiling, but then they realize that this is more complex than expected. So just getting the right data, running the detailed analysis for each project, and repeating it for across the entire portfolio require tools, workflows, and time that most teams do not have. This is the problem from the point of view of soiling, but there is also room for improvement regarding the cleaning strategies that are defined today. And in general, from our experience in PVRADAR, we have seen that cleaning strategies are really far from the optimal. Some organizations tend to believe that just cleaning it's enough. So cleaning or setting cleaning, regular cleanings from once to twice per year. But every project is a different world. So you should really check case by case how the soiling losses balance with the costs of cleaning to understand what is the optimal cleaning strategy that you should be performing. Because sometimes you have under cleaning, you clean less than what you should be cleaning, and you have still a lot of energy that is being lost through soiling. And in some other cases, we have seen power plants that are over clean. So they are really over or spending more than they should in cleaning costs. And we'll be talking about that also during the demo. So that brings us to our first poll question before jumping into the demo. This will be interesting starting point for us to understand what is the situation here. Let me just post I'm going to launch the poll here. You should be able to see it now. So we'll give you some time to answer. How do you currently estimate soiling losses for your projects? So do you assume a fixed yearly average, for example, 2%? Do you rely on personal or industrial experience? You maybe use a custom spreadsheet or Excel model. Do you go farther and model soiling uses PVLib or similar approaches? Or finally, do you conduct a soiling measurement campaign? We see that most of people model soiling losses using PVLib or similar, or assume a fixed yearly average. Great, we have enough responses already. Great, and with that, I think we can jump into the next part, which is how we as PVRADAR, we solve this problem. So for us, it's all about our methodology, which is from data to decision. We don't trust in these generic assumptions. So everything starts from, it's a clear 3 steps methodology. We start with accurate soiling estimation. That's the base for everything. Then that allows us to jump into a detailed yield modeling to convert those potential losses into actual energy losses. And finally, we take a look at the financially optimized decisions. The soiling modeling, well, everything starts with accurate soiling estimates that are specific to each project. And those estimates are built on 20 years of historic data and fine-tuned with site-specific measurements. We have access to a large database of soiling measurements across the world. This is not a generic model, but something that produces results, specific results for each power plant. Then the real impact of soiling and cleaning on energy yield depends on some plant characteristics, such as clipping, curtailment, tracking configuration, and so forth. And our yield estimation model takes everything into account and translates soiling and cleaning scenarios into the real impact on energy production. And finally, the final step connects energy impact to financial decisions by evaluating cleaning strategies based on lifetime cost. We're able to help teams maximize energy production while limiting or trying to minimize the cleaning expenses. Something really relevant for us is are our trust badges. So we are proud to mention that the PVRADAR soiling model has been validated as the most accurate in the market, and not by us, but from third parties. So each of them, the studies on which we validated our model, they used RMSEE as the accuracy metric, and they compare performance against standard models from the literature. For example, you see in the image we have PVLib, HSU, we have Kimber, which are the standard approach so far. And in all the studies, PVRADAR showed a higher performance, a higher accuracy. So we have these studies available also in our website. You can see how Total Energies validated the PVRADAR model across 9 different sites in the US. The same we did with data from NREL in the western part of the US. And finally, Leeward was also, they performed one analysis for PV site in California, which also concluded that PVRADAR was the most accurate model. This is our team. We are 3 co-founders. Tore and I, we come from the PV industry. For 4 years, we were working for a big developer, and we were responsible for assessing site risks for a growing portfolio in a new region. And one of the biggest topics, of course, was soiling. We were trying to estimate how soiling would impact our new power plants. We tried at first working with soiling sensors. We evaluated and tested different cleaning technologies and tried to translate that knowledge into better risk assessment for the new projects. Along the way, we experienced with the generic assumptions. Then we tried to model something simple using Excel. But at the end, eventually, we realized that the tools we needed simply did not exist. So we partnered with Constantine and his development team to build the tools that we would have liked to have back in the days. So this is basically a modeling framework created by PV developers, PV professionals, for PV professionals as well. And with that, I think we're ready to jump into the live demo. David, I'm gonna give it up to you. Yes, perfect.
Yeah, great, Franco. So glad we set the stage the way that we did. I'm excited to show you guys the software itself. So what you're seeing on your screen right now is a 70 megawatt project in Brentwood, California. I've done a 3D analysis on this, and so you can see some of the 3D results in here. We have some topographical anomalies that are kind of interesting on this site, and you can see the way that these little hills on this site are resulting in some extra shading losses on the east and the western side of that. We also have some transposition gain on the northern side here as the trackers are south facing, and probably a little bit of loss here on the southern side. However, this webinar is not about shade loss. We're talking soiling loss. So let's back out of here, and we're going to go into our weather data, you'll notice that I've modeled this with a 2% soiling loss, which aligns with 33% of the webinar participants in today's webinar. It's a pretty standard practice to do that. And so now when I run my prediction in PlantPredict, it's going to take that assumed 2% loss, apply that to my prediction values, and we'll see what kind of energy results we get on this project. So this project is predicted to produce around 139 gigawatt hours of electricity with a specific yield of 1969, and that's with my 2% soiling loss factored in. All right, now what I'm going to do is I'm going to show you guys how we use Claude and a beta MCP MCP server connection, to actually interact with this project in PlantPredict. So you can see I've already connected Claude in to look at this project in particular, and I'm going to just ask Claude. I went off script here just a little bit. Let me clone this, because what I want to do is, that was using standard 2% defaults, but I am going to do another prediction, and we're going to call this prediction location-specific soiling losses. And we're going to use PVRADAR to bring in those location-specific soiling losses. All right, now back onto script. What we'll do is we'll drop into Claude this question. So I'm basically asking Claude to take a look at this project, know its location, and then estimate how I could maybe do an optimized cleaning strategy on this project. All right, so now what I'm going to do is I'm going to go into PVRADAR, and we're going to generate those location-specific soiling losses. All right, I've logged into PVRADAR. I click Create New Project. We're going to call this Cali Solar PVRADAR. Specify that it's a PlantPredict soiling and cleaning project. That's going to trigger the API connection between PVRADAR and PlantPredict. And it's going to pull in all of my active projects. So I've got this Cali Solar project built into here. And I'm going to say, use this prediction. Now what's happening is PVRADAR is pulling in all the prediction details. So it's going to have things like GCR, DC-AC ratio, my modules, my trackers, all of those factors that are important in doing a soiling analysis. It's going to show me just a quick overview there. Now what it's doing is it's generating the soiling model for this specific location. It's important to note that the soiling model here is going to be very detailed, so it's more than just monthly averages. It's going to actually give me daily soiling values, so you'll see the actual soiling increase as the month progresses. It also is going to pull in rain data, because the most significant thing in any soiling model is the rain that happens, because that is nature's way of cleaning your solar panels for you. What's cool about PVRADAR is PVRADAR has both satellite-based rainfall models as well as weather station-based rainfall models. So you get a choice of how you want to model the rainfall on your site. I personally like to use the NOAA weather station-based rainfall predictions, rainfall models. I find those to be the most accurate. So we'll see what this looks like here in a second, once the soiling model comes in. All right, there we are. So you can see with this box plot that the soiling really ramps up during the summer, which is why we're doing this webinar today. As we enter into cleaning season, it's important to be thinking about this. And now I'm going to switch over to the NOAA rainfall data, and you'll see how the box plot does shift with that. All right, we're going to hit next. We do have some financial assumptions, because when we do our optimization, it's important to have some financial inputs and so in order to identify the optimum approach. Okay, we're going to use this no cleaning variant. The no cleaning variant is going to be our baseline. And I'm going to just go in here to PlantPredict. We're going to say apply in PlantPredict, which is going to take these detailed day-based soiling values. We're going to use the median. We do have a choice between medium, min, max, P90. Averaging out across the year, we're at 4.32% soiling loss. And we're going to pass that into PlantPredict through our API. Here I've opened the PlantPredict prediction. There's our average monthly soiling values. I don't want to confuse you here. We are actually using day-based soiling values in this prediction. All right, one thing that I have to do, since I'm running a 3D model, I do have to rerun my 3D analysis. The reason why is because soiling affects the optical portion of the energy prediction. And so it's important that we have the soiling factors factored into our shading calculations. So I do have to rerun this. The good news is PlantPredict's 3D analysis runs on GPU-based servers in the cloud. So despite the fact that this is a 70 megawatt project, we're able to run a 3D analysis in under 30 seconds. So it runs relatively quickly. So redoing this 3D analysis is a breeze in PlantPredict. It's really not that big of a deal. And so I think that's a huge differentiator for our product. All right, now I'm going to run the prediction to see how that pencils out from a energy production perspective. And while that's happening, I'm going to come in to Claude and let it do its thing. So it's now reaching out to get the predictions. The timing should be just right because we just finished our prediction run. So let's see what Claude is thinking. And while it's doing that, I'm going to just open up the energy results. So if you remember, we were at about 139 gigawatt hours. Claude needs to get more information. One thing that's cool with Claude is it does ask to make sure that it has the permissions that it needs. So we're at 139 gigawatt hours. Now we're at 135 gigawatt hours with the location-specific soiling losses. And you can see the soiling losses are now at 4.84%. All right. Now, Claude is going to be my performance modeling assistant. It's thinking hard here as it's going through and pulling the results. One other thing that I can show you while it's doing its thinking is you also can do like a side-by-side analysis. So if I hit this compare multiple results and look at these two predictions side by side, this is kind of the traditional way that we look at PlantPredict results. I can scroll down and I can see my soiling values here, and then my side-by-side prediction results right here. So 139 to 135, specific yield 1969 to 1913. All right. Yeah, I think I had the timing just a little bit off. This is definitely an adventure trying to bring in AI into this demonstration to see how this works. So let's see how long it takes Claude to come up with this. And so, all right. Still thinking. Come on, Claude. There we go. So one thing that is kind of cool is it does do these visualizations, which are helpful. So it's telling me pretty much what I just showed you, which is that we have this 4.36 gigawatt hour gap, 3% loss. Now, this is just really important because if you're using 2% as your baseline, you're not getting, you could have a blind spot on exactly how much soiling is affecting you if you're building a project here in California. It does look like Claude is giving me some idea of what could be recoverable out of this, which is kind of cool. So there's some charts to just show the various months and what the soiling impact is, how that translates in gigawatt hours on a monthly basis. And then it's recommending definitely during the summer is my biggest opportunity. So that's kind of cool. All right, so cleaning strategy upside. With targeted cleaning focused in the July to October window, you could bring back 3.5 gigawatt hours. So it's giving me somewhat of a guidance on what I could do from a cleaning perspective. But let's see what PVRADAR recommends. So I'm going to come back into PVRADAR and I'm going to add a cleaning variant. We're going to use this standard tractor dry service, which I think is a good baseline package to use in PVRADAR. I'm going to say user define 2 tractors because I want it to be realistic. If I said optimize, it would use as many tractors as I could fit onto the site. But I think realistically, we're going to do 2 tractors, but I'm going to allow it to come up with its own soiling level threshold and optimize this based upon the costs involved here. So the process is off and running here, and you can see with this little spinner, it'll give me some sort of feedback on how long this takes. One thing I want to point out is I'm not using like pre-staged simulations or cleaning runs because I want you as a webinar participant to actually see how long these processes take in real life so that you have somewhat of an understanding of how much time you're going to have to wait when certain things like this are running. And so one thing that's kind of cool, if you are using a performance engineering assistant like Claude, you could kick off a process like that and then come back over here to Claude and ask it questions and kind of run two scenarios in parallel, which is actually how I work quite a bit. All right, so now we're at 96%. The process is completed. So PVRADAR is telling us that this is a good strategy. We're looking at a $2.3 million NPV on this approach. We're going to clean with 2 tractors, 11-day duration. We're going to clean whenever the soiling reaches 7%, and we're going to clean 1 to 5 times per year, which is interesting. Now, what I'm going to do is I'm going to come over here to PlantPredict, and I want to pass over to PlantPredict the updated soiling results. I can see a quick glimpse here of what this cleaning strategy does. So it lowers my soiling loss from over 4% down to 2%, right around our baseline. But I'm seeing the details on a daily basis. All right, now let's come into PlantPredict. I do have to rerun my 3D calculations once again. I'm just glad that it doesn't take very long here. But while it's doing that, I do want to just highlight. So we are doing our cleaning. You can see the cleaning in these yellow bars. So we're doing our cleaning when we hit 7%. And one thing that I really like as I come back through here is I can see my box plot. I can see my financials, including a cash flow analysis. So on an annual basis, the green line is additional revenue. The blue is my variable cost. So you'll notice that the additional cash flow revenues is higher than my cost across these. All right, let's kick off this prediction. And when I go to the yearly production tab, we see the data on an annual basis, including how many cleanings we're doing each of these years. So year 1, we did 1 cleaning. Year 2 was 1 cleaning. In year 3, we did 2 cleanings. And then in year 5, we do 4 cleanings. So PVRADAR manages how frequently and how many cleanings we're going to do. All right, so my prediction results are done. I'm back up to 138. So if you remember, we started at 139 with just a 2% default. We went to 135 with the location-specific actual soiling model, and we almost reclaimed all of our cleaning with this optimized cleaning strategy, all the energy with our optimized cleaning strategy. So now what I'm going to do is I'm going to have Claude analyze this for me. And so in this prompt, I'm just asking Claude to take a look at all 3 of the predictions and the prediction results, and then look at this as though Claude is a senior performance engineer, even though it's my performance engineering assistant, and let me know what it thinks of the results and how this compares. So while it's doing its AI stuff, I'm going to just continue to do the analysis myself by coming back here. And yeah, so actually we have the two. I missed that as well. So we only have the two predictions. I forgot to do the clone there. So, well, let's see what Claude comes up with anyways. So it says that it noticed that the location-specific soiling loss prediction has been updated with the optimized cleaning soiling factors. So let me pull the full results for both simultaneously and see what the results are. What's cool is Claude should have memory of the previous one as well. And so what I'll do is I'll have it try to understand the results based upon that. Tell you what, we can come back to this because Thor's going to go into a little bit more detail on PVRADAR. So Thor, Franco's going to go into more detail. Franco, how about if we hand back over to you and let you go into your section right now?
Sure, happy to do so. Let me share my screen again. Right, so basically what I want to do here is go a little bit further and explaining to all of you that with PVRADAR is not just a tool that provides site-specific soiling values and finds the optimal cleaning strategy. It's also a decision support platform that allows users to evaluate different cleaning technologies and different operational strategies under the specific constraints of each project. So to demonstrate this, let's look at two practical use cases. The first one is evaluating a local cleaning technology. So let's assume we are defining or we want to make a decision across all the cleaning providers that are available in my area. Let's assume we launched a cleaning services tender and one of the proposals offers a specific tractor-based solution, and they provided all the technical specifications and all the associated cleaning costs together with their proposal. So what we can do here is not only evaluate standard technologies, but you can create your own technologies. I'm gonna show you how. In the left bar, we can see that we have access to a cleaning technologies database. We click there, we are redirected to a database that is populated mainly with standard solutions that we have created based on our best guess through all the years in this subject. I can quickly go here and create a new technology, which I will call Tractor Wet Cali, just to say that it's specific to this project. It's a cleaning provider from the area. And PVRADAR asks me for the type. I'm gonna say it's Tractor Wet. And you'll see that the first thing that PVRADAR asks me is, okay, what are the main characteristics, the operational parameters of this technology? It assumes that it requires 2 operators per system to be operating. The cleaning speed, it's also assumed to be 6 kilometers per day. Let's assume this is a super a faster technology that increases that to 7. There is a cleaning efficiency which is associated to the cleaning method. In this case, we're using water, so it's fair to put a high efficiency. It has, of course, water consumption associated and a fuel consumption, which we can also change and say, okay, this tractor turns out to be faster and also more efficient. Let's see what happens and how all these parameters have an impact on the final result. With that, I can now jump into the cleaning packages. Cleaning packages are how the specific technology it's gonna be used. So it's everything related to the costs, right? So I can create a new package here, which I'm gonna call the same way, tractor wet Cali. I'm gonna tell PVRADAR that looks on all my tractor wet technologies, and I want to do a service because it's the most typical, the most standard for the in the industry today. But you can also select an ownership and define all the prices and costs that will be involved into you taking care of the cleaning itself. Service, and since I selected tractor wet, it gives me as options the three tractor wets that we have in our database. So I'm going to use the tractor wet Cali. It's the last one I created with all the parameters that you just checked. Okay, I have now a summary of my technology, and here I enter into the costs sheet. I have a simplified version, which is only composed out of one single value. So what is the cleaning cost per megawatt peak? Or I can also access the detailed cost model where I have a full understanding of all the costs related to the execution. So all consumables, everything related to operators and labor, water costs, fuel costs, and even transportation and so forth. I have also a field for maintenance, yearly maintenance, what is the value for my technology. And finally, I have something for replacements and spare parts. So I could enter a single value, or I can really go into the details and add components. So for example, I could say that my tractor brush is of course a brush, and it has a lifetime, certain lifetime, and it's measured in years or in operative hours. But let's keep things simple. Let's go back to the simplified model, and let's assume the local cleaning provider is charging me $450 per megawatt clean. We're going to save this. And finally, once it's ready, I can go back to my project, which is Cali Solar, PVRADAR, back to my cleaning variants. And here what I'm going to do is, okay, let's now evaluate how the assessment changes now that I have a new cool tractor that is faster and more efficient. Let's use my tractor wet Cali, use this package. And same as David did before, I'm going to limit these to 2 tractors because I want to be realistic. But I'm going to let PVRADAR find the optimal soiling level threshold. So this means what is the soiling level that after that value is reached, I should trigger my cleaning activities. That's the way on how PVRADAR finds optimal strategies. There are more ways on how you can define a cleaning strategy. I'm going to go through. I'm going to show that just in a second. But for now, let's see if this new technology yields a higher result than what David found before. And I see on the left, I have my loading bar already. It's halfway through. And then when it's fully processed, I'll have immediate access to the overview, which will tell me the main characteristics of my cleaning strategy, and also some detailed views, as David showed before. What are the soiling levels with and without cleaning? How, what is the status of my financials after finding this optimal strategy? What are my investments? What are my revenues? Then my yearly production. Here it's important to understand that we defined that our plant will have a 30-year lifetime that was defined in the previous step in financial model. But of course, depending on the lifetime, it will provide different results. And finally, I have the PlantPredict tab, which allows me to interact directly with my prediction in PlantPredict and transfer results. Okay, I see, first of all, I have green numbers, so that's good. Cleaning with this tractor is profitable compared to the no cleaning scenario. And what exactly am I doing? I'm using 2 tractors. Each cleaning cycle will take 10 days because it's a big power plant. And PVRADAR suggests to start cleaning every time soiling level reaches 6%. Before it was 7%. Now PVRADAR finds this to be more convenient, so it triggers more cleanings. And if I go back to variance just to compare, I have here my overview. So this is the chart showing the total lifetime cost. I see that I have three scenarios. The no cleaning scenario, which is the base scenario, it is only red because it's made up of lifetime soiling losses. It doesn't include any cleaning cost. And then I have the two cleaning strategies that I'm comparing right now. So the one that David created and the one that now I've optimized, and I've came to an even better result. So we jumped from $2.3 million for the entire lifetime of the project. It went up to almost 2.6. So the first message I want to give with this is you can go really into details and evaluate the offers from your cleaning providers in your area into PVRADAR, so PVRADAR can really tell you which of all the solutions is the most convenient, not only the cheapest, but the one that in the long term will be the most profitable. That's the first use case. And the second use case is that I understand that some operational teams already have a way on how they are cleaning their power plants. Most likely it's something schedule, like a fixed schedule, like once or twice per year. I'm going to show you that not every cleaning strategy is profitable, and therefore you should really be aware of the strategy you're using. So I'm going to duplicate this strategy. That's something that you can do real easy with PVRADAR, and I'm just going to call fixed schedule. There I am, apply. And now if I go to the details, I don't want to optimize the strategy based on the soiling level. I want to give specific dates. I want PVRADAR to analyze how convenient is my current strategy. And my current strategy, I'm cleaning twice a year. The first cleaning is always mid-April, or well, let's keep it to beginning of April, 1st of April. And then my second cleaning is always scheduled to August 15th. So if I apply this strategy, I'm going to see, okay, how good or how profitable is my current strategy, and how far am I really from the optimal solution. This is going to take, well, it's going to be faster because I'm not optimizing anything. I'm just evaluating. And you see that, well, green numbers, this is still profitable. Cleaning this way is still recovering energy in an efficient way. But you see that now we are way closer to the no cleaning scenario rather than the optimal. So there is an important amount of money that I'm still losing. And this is just because I'm not optimizing my cleaning strategy. You see, my maximum would have been $2.6 million, but I'm just reaching not even half of it, right? So there is a lot of potential that I'm missing. And that's my second message. Not every cleaning strategy is correct. You can use PVRADAR to evaluate how profitable your current strategy is and find the room for improvement. Right? So with that, I think we can jump back into the presentation. David, I'm gonna from here, but let you, I think for time constraints, I'm gonna skip the second poll question to jump into what is really important. So why or how can you start using PVRADAR soiling extension today within PlantPredict?
Thanks, Franco. Very interesting stuff. So on this page, you're seeing our PlantPredict pricing table. So PlantPredict, very transparent with their pricing. That's all part of our model for solar modeling made simple. You'll see that we have core product and the pro product. The core product gets you access to PlantPredict's core energy modeling. Pro brings in our pro tools like Design Pro, Terrain Pro, and Voltage Pro. All the way to the right, we have our extensions. The PVRADAR soiling extension has been, as a bundled product, discounted slightly over the PVRADAR list price. So you can add a PVRADAR extension to your PlantPredict subscription for $15,000. That gives you all you can eat, as many projects, as many predictions as you want. And it spans for all your users. So every user can do this. So for $15,000 a year, you can gain access as many projects, as many simulations, for as many users as you want, you can do that with PVRADAR, which is a very good deal. However, let's go to the next slide. To celebrate cleaning season this year and to really incentivize you guys to take advantage of this powerful capability we just demonstrated, we're rolling out what we're calling our PVRADAR cleaning season promotion. We're implementing a project-based pricing model during this cleaning season to see if this is something that's interesting and desirable for the market. You can get a 5-pack of projects for $5,000. It's $1,000 per project. You can also buy 2 of those packs for $10,000, and that gets you 10 projects. It's an unlimited simulation, so unlimited variants. You can run as many variants as you want, but you can only do it on as many projects as you have packs for. Obviously, if you wanted to do a 15 project pack, you might as well just buy the $15,000 version, and then you have unlimited projects. All right, what I want to do quick is I'm going to ask Claude, if it's going to cost me $5,000 to buy a license of PVRADAR to model this project, is that a good deal or not? And the answer is decisively so. The math here isn't even close. So if we look down here, it's going to explain to us why this is such a good value. One honest caveat, though, we should pay attention. The $5,000 buys the analysis, but it doesn't execute the cleaning. The cleaning contract is separate. Real operational costs, although we have a better idea of what the cleaning costs are because PVRADAR modeled that for us. But the bottom line is $5,000 for a site-specific defensible soiling model that corrects your P50, de-risks your contracts, and optimizes your O&M schedule is one of the highest ROI decisions you can make. So Claude is clearly in favor of this subscription, so you may want to consider that. All right, so we'll go back to the presentation to finish this out, Franco. All right, so how do you get started? In the post-webinar survey, you can declare that you're interested in giving this a try, and we will be happy to give you a trial. The trial that we are setting up for anybody that wants to give PVRADAR a try is you're going to be able to do 1 project, and you're going to have 14 days to run as many cleaning variants as you want on that project. So we're basically giving you free access to this tool for 14 days so that you can give it a try. And we recommend that you give it a try. I mean, you can pick the one project that gives you the most trouble and actually model that very effectively in the 14 days. So you should give it a try. If you're not participating in this webinar live, you can always send an email to support@plantpredict.com and say that you're interested in subscribing to PVRADAR, and we'd be happy to do that. So with that, I think, I do want to mention Intersolar is coming up. There's been a lot of chatter on LinkedIn about Intersolar. Both PVRADAR and Terabase will be at Intersolar. I unfortunately won't be there, but my good friend and colleague Tang is going to be there representing PlantPredict. We also have our leadership team, like our CEO and Pierre is going to be there, and I believe the entire PVRADAR team is going to be there. So look to booths A3740 for Terabase or C4 450F for PVRADAR. And now I think we're ready for Q&A.
That's right. Thank you very much, David. And right now there is room for Q&A section. I just wanted to remind everyone, if you have any questions, just feel free to drop it in the Q&A section in Teams. So far, we don't have any questions, which means probably our David's and my demo was pretty clear. I'm happy to see that. So we're gonna give some minutes. We'll wait for any question that the audience might have. Otherwise, yeah, I would like to encourage everyone as well to try out PVRADAR. Bring us the most challenging project you have. I'm sure we'll be happy to see how we estimate site-specific soiling, reduce the risk during the early development stage, and the most convenient, increase the project value for your project by just finding the optimal cleaning strategy. So I think, David, there are no questions. I don't know if you want to add something else before closing the meeting.
I don't think so. So I think that this may be where we end.
Perfect. So thank you very much, everyone, for your time, for your interest, and we're happy to support you in your soiling and cleaning challenges. Thank you, David. See ya. Bye-bye.
All right. Bye.